Hi, I've made this video for you because I'm very keen on encouraging you to maybe design to one of our platforms called Sensi All. So in front of me I've got the Sensi All platform. I appreciate that you have seen it, but maybe I want to sort of give a little bit more of an introduction to it. So I'll use this video now to give a bit more of an introduction to it. So I've made some slides specifically, and I apologize for the slight spelling mistake there. I realize this is phase 0. But that said, you do have, and obviously a very good reputation for making good screen printed electrodes over the years. And at the moment, you're making these screen printed electrodes to a certain dimension in terms of width and length, and even a certain thickness. So what I will be saying is that we would hope that you would consider also designing some electrodes to the form factor, or the size dimensions, I should say, that we would require for this as well. So you can see that this is a very new type of potentiostat. I know I showed it to you physically, but I will also demonstrate it now and talk about the sort of pros and cons of this particular platform. With that said, let me go forward a little bit more. Just to say that obviously, because you've put your reference, your working, your counter in the same place, that means that you are partially mechanically aligned with us at the moment. And I know that you would have used the same kind of pitch between the distal end here that we would have used, and what many vendors in this space now do use. So there's some parts of your designs that already make you compatible with us, but I'm just going to talk about width and length, that if you just subtly, if you did change them, I'm not sure if it's subtle, then you would be more compatible with us. I appreciate that the dimensions that you have today do make you very compatible with quite a few of the sort of potentiostats that are out there on the market today. So I do understand your driver, and I'm asking you to make some slight modifications that you actually can become compatible with our potentiostat. Our potentiostat actually has a vision, and the vision is that we're actually trying to close the valley of death. Now, when you do your phase 0 product, you're obviously thinking about people in the early days of their research, and realistically, because of your volume capabilities, you really want those people to go on and commercialize. And actually, at ZP, that's also our intention as well. So you would give people screen printed electrodes, and we would, and you want them to go on and be successful. Now, because you're now starting to face this kind of, well, you've been facing it for years, but you're facing this market that's more R&D and slightly academic. ZP's also been facing that market for a few good years as well. And we've kind of realized that, of course, there's a high attrition rate, and very few of this technology actually hits the market. And it's in part due to the instruments that people are using. So what we're saying here is, let's help people to actually get across this valley of death between research and commercialization. Now, this you could talk. You use terms like phase 0. We could use terms like technology readiness levels, TRL1. You could almost be your sort of phase 0, or your TRL2 could be your phase 0. But there's TRL1 to 9, and you wouldn't want them at 9. Sorry, you want them at 9. You're helping them in the early days now at phase 0, and there's always been this perception of a large gap between TRL1 and TRL9. Now, at ZP and governments and SBIR grants and NIH, etc., are all trying to kind of close that gap. And I think actually we can partly close that gap and make it shorter. So we kind of call it the 2-year manifesto. Why does everyone take 20 years in the end to fail, when actually, let's get people to market within 2 years. But in order to do that, we want to we have to change something, and of course what we're trying to change is essentially the instruments upon which they are building. Everyone is reinventing electronics all the time. Electronics are already quite robust. Let's talk about encouraging people to get to market quicker, and that's what this presentation and this demonstration will be about as well. So I will talk about this Sensi All potentiostat. It's quite a unique way now of actually making a potentiostat. It's not only a potentiostat, it's also what I would call an MVP, a minimally viable product as well. I mean, at ZP, we're taking direction from the sort of tech industry, you know, where they actually, you know, fail fast or succeed fast, whichever way you want to sort of spin that. But we do want people to succeed fast, and that's why we've built something that's much more akin to a kind of a consumer type grade product. Even though this is a potentiostat, you will see that in fact it's, I want to say, more than just a potentiostat. It's actually a minimally viable product, but that's what I'm going to be talking about in this slide deck now. So we talked about Sense It All. Sense It All works with screen-printed electrodes. Screen-printed electrodes can be biosensors as well if they're functionalized correctly, and it can receive samples. So, you know, great thing about screen-printed electrodes, you don't need much sample. The great thing about the Sense It All, Sense It All potentiostat, that it's driven by an app, and that app is available for download off the Apple App Store or the Google Play App Store as well. Now, that app is actually driven by QR codes. When you look in front of me at the moment, I've got all these QR codes. So a lot of your kind of academic interactions, they'll be doing things like amperometry, open circuit potentiometry, electrochemical impedance spectroscopy, linear sweep voltammetry, cyclic voltammetry, square wave voltammetry. This app, which is connected to that potentiostat, knows what to do because it's got a little, I'll just touch a button here. I've got a little QR code reader on that app. And so when I scan a QR code, which I'll do now, it comes back and it actually changes what the app is actually able to do. So no menu. So it's already feeling much more like a 2024, let's say, product, not a kind of Windows menu driven potentiostat that we would typically be sort of used to. So let me go back to this screen. So it's smart device driven. The smartphone knows what to do through QR codes. It's in Bluetooth connection with the device. It will instruct the device what to do. It gets instructed. The app is instructed by the QR code. The app tells the meter what to do. The meter gives the data back to the app. In this case, for example, cyclic voltammetry. And then, this is really getting into the world of data science. It actually sends a raw signal to a cloud system called Julie. At Zimmer Peacock, you know us for screen-printed electrodes, you know us for electronics, you know us for biosensors. Julie is a completely in-house built data management system for electrochemical data. So the data is sent to the cloud, we process it, and this is the good thing. The user, whether it's us, whether it's you, whether it's your customers, can put calibration routines into that cloud, and actually we can process raw signal and send back concentration, for example. And that's the bit that really closes this idea of most laboratories. If you do a proof of principle in a laboratory, it's called technology readiness level number 3. But that's no good to most people because they don't want to do electrochemical experiments. But in fact, this will turn electrochemical signals into actual concentrations and send that concentration back to the smartphone. And now you have a much more matured user experience. So I'm going to just do a quick demonstration for you now. So this will be a quick demonstration. So I will, for example, I'm not going to do square wave voltammetry today, but I could have done square wave voltammetry and actually do an analyte demonstration for you. So I'll take pipette, take a sample, put it on here. So potentiostats, and we can then turn it into analyte specific as well. Understand how quickly somebody could go from just a laboratory experiment to actually doing something that's kind of more useful to other people. When I say other people, I mean sort of end users. And off we go. So the progress bar is turning. The device is actually doing the technique cyclic voltammetry. I'm actually just working in the background, just opening up a system called Julie. Julie's a cloud system. I sort of said that the data will get collected by my phone and then will actually go up to the cloud. This is very useful for people who are developing apps and technologies, which is what should come to an end now. So now it's come to an end. I'll bring that up to you shortly so you can get a better look at that. In fact, what I'll do is I will change my screen here. Whoops, daisy. Here it goes. Yeah. so that is actually put a, sorry about the brightness of it. Yeah, so it sent the results to the cloud, and it has turned the results into a score, if I can put it that way. Now what I'm going to do is I'm now going to share my screen with you. So that gives it a real user experience, because in fact, rather than it being like cyclovoltammetry, it's actually given it in micromolar there. And then I'm just going to share this screen with you. This is a system called Julie, so julie.zimmerpeacock.no. I'll just go demo, go into that cluster, go into the device. That was the label I just gave the data. And up in this cloud now, I've got the cyclovoltammetry experiment that I was doing, but I also have something called a data pipe, where actually I was able to tell the system to analyze that signal, turn it into an actual concentration. So cyclovoltammetry, many of our users will be doing it, amperometry, square wave voltammetry, impedance spectroscopy, that's what they'll be doing. But the data pipe that we've then built in our cloud means that they can actually then go onto that next part of the thing, when I say thing, the workflow, and actually we can tell them where to look for the data, we can tell them how to treat the data, and then it will actually give back a concentration as well. So this is not a typical potential stat that kind of leaves people sort of abandoned with just their raw signal and their calibration curve. It actually takes them beyond that and actually brings them to concentration. So what we're keen for you to do is actually design to our, I don't want to say rules, but at the moment, obviously you've got a great reputation, you've been doing this a long time. What we're sort of asking is, if you make your a range of your electrodes 26.3 millimeters long, 7.2 millimeters long, they will fit on this piece of hardware and they'll become Sense-it all compatible. So I've given you a bit more of a sort of, you don't have to change this end in terms of your connectors are probably fine here. It's just the length and the width. And I've also just done a bit of a back and envelope calculation and just said, if you do that, you will be compatible with our potential stat. You'll actually reduce your area from 330 millimeters squared. Now I know you do reel to reel to 189 millimeters squared. You'll basically be able to pack in a lot more screen printed electrodes, so your production rate per unit time will actually go up by about 1.7. So you'll be able to charge the same amount for the electrodes, then be compatible with our platform, and probably have a greater margin as well. And the reason I put thank you here is just to stop you rabbiting on for too long. But that's the kind of conversation I'd like to have with you. Okay, take care. Thanks very much.